Welcome to the December 2020 DevOps for Defense. Tonight, we're going to talk about DevOps for Systems Engineering and Architecture. I'm super excited about this topic. It's something I've been kind of passionate about for years because it's something I think is relatively unique to our domain. And I hope as we go through this that we will have a good conversation and get some different perspectives on the topic. I do want to start by saying that the Zoom is being recorded, and I do publish our meetups to YouTube every month, so that if there was something that you wanted to go back and check out, or if you happen to miss one of our meetups, you can always catch up. But so if you don't want to be, visible or present or heard, that just be aware that it will be published, and so. Appreciate that. We always start with a code of conduct. Obviously, this is a classified session, so no dirty words. Ask that we just treat each other with respect and don't talk about your private, sensitive, or proprietary work. Your secret sauce is yours, and it should stay that way. But we do like to talk about our experiences, the challenges and needs that we see, and areas that we think we can use help to get improvement. Share your thoughts and try to learn from others. And I will ask that if you're not speaking, please mute yourself in this virtual context. But please don't hesitate to interject. Add some comments or ask questions. I think the interaction in a virtual world really helps make it a much more enjoyable experience. So, welcome to the 3-year anniversary. It's hard to believe that that 3 years have already gone by. We started December of 2017 with 8 people sitting around a little table at Rocket Republic, and over the years we've seen a lot of really great interaction. We've gotten to meet a lot of great people from around the community, and even now that we're virtual, it's certainly not the same, but we now get to interact with people from across the country, which I think is really great, and I've been enjoying that aspect. So thanks for coming in for the 3-year anniversary. I always try to do something special. If you remember last year, we had, we always do a cake. We bring in catering. Last year we did custom screen printed T-shirts. We actually raised over $300 from that event to support Girls Who Code in the local chapter, and it was a great time. If you were there, I really appreciate you joining us for that and helping support the the students in the community. But what a great time, and thank you all for all your support and participation over these last 3 years. So it's worth kind of talking about 2020, seeing as it's coming to a close. Kind of a quick look back at our highlights. We had a couple of great presentations from one of our community members, Vadim, looking at how Shipped, which has become an incredibly relevant service in this current pandemic world, how they build and deliver and operate their systems using microservices and DevOps and DevSecOps principles. And then he gave us a great talk in September about how to scale those services in the cloud and the criticality of horizontal scalability and how you construct and design your systems to operate in that context. One of the huge highlights this year for me was when Hans Doctor came into town. We got to see straight into the development environment at Gradle and how they are walking the talk, implementing and building capability, and actually employing the processes and efficiencies that they offer us within their own environment. It was so cool to see how they operated, how they find issues, how they've instrumented their entire release train and actually deliver incredible capability. So that was certainly a huge highlight. April through June, we kind of just shut down out of fear. Even today, I still, worry about doing anything that would put any of our community members at risk. So we did cancel for a few months there, but then decided it had been too long and came back online for virtual in July. Another great highlight this year was Darkwolf Solutions. If you recall, Darkwolf were the authors of the U.S. Air Force's Continuous ATO Handbook. Really cool stuff that they're doing with the Air Force, and they had a great presentation on fast track and continuous ATO. That is available on the YouTube channel. Actually, all of this is, if you want to go back and check any of it out. One interesting thing I did just last month that that you have probably missed is I saw a need. We talk about it all the time. We talk about how configuration management, based on the research in the industry, the State of DevOps report, Accelerate, which is a great book. From all this research and study, we discovered that configuration management is the #1 leading indicator for high-performing teams. And the more I interacted with people, the more I realized that we didn't have a solid foundation of what configuration management truly means, how it works. So for the first time ever, I did a direct to YouTube demonstration of configuration management practices and exactly how it works and how to walk through it. It is a 90-minute video about configuration management. So you're forgiven if you think that it's probably a great cure for insomnia, but you may also get some value or learn something about it, or maybe be able to share it with others who can benefit from it. I hope you find that useful. And as it says there, everything is on the YouTube channel, so it's out there if you'd like. A little public service announcement. We talked last month about some of the highlights from the DevOps Enterprise Summit that was a virtual conference this year. I just saw a week ago that Gene Kim and his organization now have gone online with that and made it available for free. So you do have to get an account, but with your account, you can go in and watch 10 videos a month. I would suggest the videos I highlighted the talks I highlighted last month. I think they were great. The talk that the Air Force did about their experience through Kessel Run and the criticality and importance of that work and how we could all learn from it, I thought was a really big highlight of this year. And now everybody can get it. It doesn't cost you hundreds of dollars. So go out and check that out. And then I always, when it's an anniversary, I like to kind of think about, we do everything here with DevOps for Defense on a pure volunteer basis as just a truly open source community. But think about how we can give back and help the next generation of engineers advance and develop. And one thing I like to do, you're actually looking at my Amazon account there. You can provide a small percentage of everything that you buy on Amazon to Girls Who Code at smile.amazon.com. This year, I'm not the biggest online shopper, but this year I got $26 to them. If 10 of us did that, that's 260. And I think it's a really great cause. Anything to help young people get involved. Get a little bit more diversity in our domain and in our workplace, and help people find rewarding careers, I think is a great thing to do. All right, enough of the preamble. Let's dive right in. So this is kind of the way I see things happening, and I am a little bit interested in your perspective on this, but sometimes as much as we see kind of old way and new way, waterfall versus DevOps, and we've talked about that a lot, I also see this interesting conflict between the systems engineering discipline and way of doing business and the DevOps discipline and way of doing business. And I see these things, potentially being in conflict. And so it's been an area of interest and research for me for a number of years that I think we've got some really interesting things we're going to have to work through. How do you bring systems engineering into the principles and constructs of flow and feedback to really help solve our defense industry end-to-end problem of product development delivery? It's not the same as the commercial world. Does anyone else agree or share the concern that that I put forward?
I certainly see the remains of that issue daily.
Well, it's something I think we're going to struggle with for some time. And so just to kind of go back to the beginnings and the principles, you look at what goes on in the commercial world. And in the commercial world, the tension tends to be focused on, development, who's always trying to build and deliver the next feature to provide value to their end users, and operations, who's always striving to achieve stability and uptime for the end users. And traditionally, these have been in conflict with one another. So DevOps has come forward and really created new ways of working that allows us to both have stable operational environments, but also continuously deliver new capability, new features to our end users. And I argue, and my premise is, in the defense industry, we have slightly different silos that we're working with. We still have development, we still have operations. Integration and test tends to be an interesting challenge in and of itself, because it has often been put to the side and independently siloed to itself. But my argument is, from development through integration and test and into operations, the commercial world provides a lot of solutions that we can adapt and tailor to our domain and our environment that will allow us to be much more successful. And as I mentioned earlier, I think the example from the Enterprise Summit this year of Kessel Run is kind of the classic showpiece that demonstrates that those commercial practices can be tailored and employed in our domain. But what it doesn't really talk about is the systems engineering challenge. And systems engineering, in my opinion, is an incredibly important and valuable part of our of the way we work and the way we build and deliver capability. But the commercial world doesn't have a way to sort of bridge those disciplines of systems engineering into the DevOps or DevSecOps flow that we can readily adopt and tailor from the commercial world. And I just want to kind of depict it as in the sort of classic DevOps problem. It's how do you overcome that wall of confusion between independent competing domains? And my argument is that the commercial world has one wall of confusion, where the defense industry really has two significant walls of confusion that have to be overcome. And so what do you do whenever you see a problem and you want to tackle it? I usually go and ask the experts. So it was back in 2017. We had the opportunity to sit down with Gene Kim, and we had a whole hour and a half block of time set aside for this topic. Gene, how on earth can I integrate systems engineering into a DevOps execution approach? And I was kind of sad to hear him say that the reality is the commercial world doesn't work like that. That it's not a problem the commercial world faces. It's unique to our industry to some extent, and there isn't a solution out there. So let me pause there and ask you guys, what do you think? Have you seen solutions or techniques or practices from the commercial world that could help us bridge this? Do you have any insight or experience that might give us some path forward?
So I keep coming back to their tests are often feature-driven tests and not necessarily, especially for software deliveries. Maybe for something where you're integrating software and hardware, like automation of an automobile plant or something, there may be examples there where it's a much more complex system. But I just don't find ones online when I look.
Yeah.
So I kind of wonder if we're trying to solve for the wrong problem. And like from a commercial space, right? It's very much focused on what's the what's the value add that you're trying to go for, right? And so it's focused on drive that solution and move to it. And I think maybe sometimes in this environment, we're focused more on the artifacts, right? The outputs as opposed to the outcomes. And if we were to separate out what are the most valuable aspects of systems engineering that we're trying to incorporate and that we want to drive through versus, a lot of the more traditional aspects in terms of requirements documents or other things like that, right? I mean, so like in, was it Mick Kirsten stuff, right? He talks to that somewhat from the flow perspective, right? And focusing on the features, and then the tech debt, and so some of those things are, I think those are directly related in systems engineering, right? In terms of features and the requirements and the new capabilities, tech debt driving down or dealing with technical obsolescence, right? But he focuses on it from that perspective, as opposed to, how does that flow through to enable an outcome, as opposed to flowing through to create a product.
Yeah. I think there's aspects of what you're saying that's absolutely true, that are put in place largely by the bureaucratic nature of the environment we work in. Excuse me. The heavy reliance on documentation, which often feels like documentation for documentation's sake. But I also see a lot of value in just I'll say the top level issues of problem solving. I see in really effective systems engineering organizations, I've seen some incredibly creative and productive people doing some pretty amazing stuff. It just tends to be done in a way that doesn't have a direct impact on the program of record baseline. It tends to be done on the side. Another area that I see a lot of interesting value is really understanding and capturing the nuances of system behaviors and system interactions. I'm always surprised, especially in our domain, how complex the interactions between systems truly is, and how often unsatisfactory the documents that we rely on to establish interfaces between systems, really are. There's always emergent behavior when you bring systems together, and when you're dealing with, complex multi-billion-dollar systems that have to come together and have to work perfectly every time to achieve a mission. There is real interesting, complexity there. But there's also a lot of complexity that we generate that's, I think, low value or no value in some cases. So what helped in the commercial world when they were bringing development and operations together, and are there any key principles? Well, so this is, you've seen all these before. This is straight out of the State of DevOps report, and I kind of looked at two of the key areas: technology and automation and process, as potential enablers in this space, and I think that a lot of these apply in this problem space. I think that things like small batch development or small batch work planning has real value. I think that having good configuration management and version control has a ton of value. I think that managing test data has a ton of value. Establishment of test automation, especially in a requirements-driven environment. We always talk about, is my requirement testable? And we often just check a T box in doors and say, of course it's testable. I put a T or an A or a D or an I in place. That doesn't really mean it's meaningfully testable. And I can't tell you how many bad requirements I've seen come through over the years. So having, a focus on test creation and automation as you're creating those, what are really requirement specifications has a lot of value. And then one I think is also critically important, especially now, is shifting security left, not only in the development world, but really treating and understanding that your security controls are requirements like other requirements and should be treated with the same rigor. But to make that work, you've got to have lightweight change processes, because oftentimes those security requirements are evolving at the pace of the threat, and the cyber threat certainly evolves faster than what we see with other threats in the domain. And so I see a lot here that can apply, and I do have a fundamental assertion here that we'll build off of later. When I look at, what was that critical enabler that brought development and operations together? To me, one of the, not necessarily but one of the most critical technologies that enabled that union was infrastructure as code. All of a sudden, I had a way to rigorously configuration manage my environment, my platform, my systems, how my software was deployed, how it ran. I could monitor drift in it, right? I could do all sorts of interesting things. And I could do it in a way that had more control and rigor applied to it. And so that's my assertion. I'm not saying that other things aren't, also, really important, but I do still come back and think that one technology that came into play, I think was a bit of a phase shift. We've all worked in the domain long enough. There's always been that master system administrator who you could always rely on to just know the state of the system and its configuration, and know how to go in and have the credentials to achieve the outcomes that you needed. Well, this really shifted that and kind of democratized it, such that an operations person could go in and make a change to that baseline and actually see it go through that same rigorous process of release and achieve the outcomes that they wanted through standard single process that was also employed by development. And so how do you take that and apply it into this problem space that we've laid out? I think there's a few, really interesting technologies available right now. One of them I'll assert is model-based systems engineering. And I think this chart really sets up the question, what does a systems engineering baseline, systems engineering and architecture baseline look like to you? And I think that, how you internally visualize and conceptualize your systems engineering baseline and architecture is kind of a key question. Have you guys had any experiences in this domain that you thought were particularly valuable or effective that you could talk about or share, in terms of what does that baseline look like for you? Or any horror stories?
So I've got one that started as one and kind of ended up the other. I was in a proposal, and a lot of the effort was very hardware based and not software based. And our piece of the product was very software centric. And the entire program, it was mandated to do model-based engineering. And for a while, they were just kind of throwing things into the tool and saying, we're doing this because we have to do this. And so at that point, it was kind of the nightmare piece of MBSE. But then at some point, all the hardware people who kept looking at me like I had 6 heads when I started talking about a software architecture started to realize that the dependencies on that software and how it fit into the overall system were something they really needed to pay attention to. So it was ugly and then it got good, but it was the only way I could kind of force that aha moment for people who were traditionally very hardware driven. So that was the benefit for MBSE there for me.
Yeah. Well, I think there's a lot of interesting technologies out there, and I do see a lot of push. I see defense proposals. I shouldn't say proposals. I should say requests for proposals that specifically ask for model-based systems engineering. And I think that there's almost in certain regards an expectation. And I've seen it applied in multiple contexts, and I've seen it work fairly well. I've seen it work very poorly. And so I think the next chart, this was my most favorite chart to build here. It really talks about, what does doing it wrong look like? And this is a pattern that I've seen over and over again, where systems engineering, really kind of does go off into their ivory tower, and they create this self-propagating cycle where they'll they'll get smart people together and they'll create some model of a system, and then they'll review that with stakeholders. They'll go to some big theatrical presentation, they'll get actions and feedback, and then they'll just rinse and repeat that whole process. And it's almost self-contained, right? They think that they're defining the future of the universe, but if you cross the wall of confusion and you go talk to the people who have to develop or test or operate the system, and you ask them, okay, I just saw this awesome model of the system, how do you use it? On more than one occasion, I've had teams, leaders of teams say, what model are you even talking about? And I think it's a significant anti-pattern in our world that in order to accomplish this, and especially if we're going to be operating in a DevOps mentality, having the work done in that model or by those systems engineers should be aligned and directly feed the downstream engineering. I think part of the challenge here that I see over and over again is really asking, who is the true customer? And more often than not, when you sit down and you talk to a team of systems engineers or system modelers, and you ask them, who's your customer? They point to the government. They point to an acquisition agency or a group of CETAs that have subject matter expertise in certain domains. And I'm not saying they're not customers. Oftentimes they're bill payers, so that does absolutely inherently make them critical stakeholders and customers. But what they overlook is the customer who actually uses their product. And when you don't deliver a product to the downstream engineering, you should have no expectation that what you're spending your hours and blood, sweat, and tears creating will actually have any effect on the realization of a product in the real world. And so finding strategies to bring these two domains together to break through that wall of confusion and actually get the systems engineering disciplines to treat those downstream engineering teams, people who build and deliver product, as a customer, and make sure that the products they're delivering have intrinsic value to those downstream customers, I think is a really key part of sort of changing the mindset in our industry. Has anyone seen the ivory tower effect in their experience? Am I alone in this?
I've seen that in some previous programs I've worked on, and they the system engineering and the architects, it's like they made the big decrees and started building things in the model and started to see some of it as like, that's not even anywhere close to how you would actually go about implementing something like that. You haven't accounted for clustering or highly available stuff or any of the design patterns that you'd want to incorporate for from a resiliency perspective and stuff. And then it's like, well, I can't already change it because we've already made this decision, and so then you're just kind of stuck. So
yeah, and I see that manifest in interesting physical ways, right? Oh, we're going to move the systems engineering upstairs, or worse, we're going to move the systems engineering team to another building across town, and the collaboration with those downstream customers just evaporates, and so you don't get that feedback that your model is pretty, but it's not useful. I think it becomes a real challenge. So my assertion is that there's something missing. And I say what I want to help address this problem is an unambiguous model of my system that has rigorous configuration management, supports small batch execution, basically checks a lot of the boxes that we saw highlighted as attributes of high performing teams in the DORA DevOps State of DevOps report. How can we rigorously capture the decomposition of the system, rigorously capture the interactions among the elements of the systems or with external entities, and how do we capture the behavior of the system in ways that directly supports the establishment of test specifications and then automation of the test cases. But I reassert, I think most importantly, how does it drive direct value to those downstream engineering teams? And what I believe is true is that we can create, we've got all the tools on the shelf, open source if you choose, to build that pipeline from development to operations, but we don't have the pieces to go from systems engineering into development. The pieces that we have are focused on creation of documents and presentations more often than creation of systems, unfortunately, in my experience. So here's my hypothesis. I think that if we use the constructs of infrastructure as code and the principles of model-based systems engineering, but we transform that into this domain, we end up with something that I will call architecture as code. And it allows those architects and systems engineers to collaborate directly within cross-functional teams, have rigorous configuration management in place, and create unambiguous engineering artifacts that have true intrinsic value for those downstream engineers. And I think you'll know you're successful when you start to see a continuously integrated model of the system, when you start to see automated quality assurance checks of that product, and you have the traceability that you need to bring you from requirement or interface specification to architectural element to interaction specification to behavioral specification and ultimately to implementation. And the better you can control that traceability, the more rigor you have and the more tools you have at your disposal to decompose and find problems in that architecture as they emerge. And then I would assert that if you do this right, you can support faster, rigorous end-to-end delivery of capability. So that's my hypothesis, adapted from some presentations Jess Humble's given in the past in terms of its format. That's my belief statement and what I would be looking for as outcomes of success. So I want to, I always like to try to do something big, and I always ask myself, what's the big thing you can do, virtually? It's hard to throw a virtual party. So this year, what I want to do is announce something that I think is super cool. There's a product now called Jellyfish, and it implements this architecture as code hypothesis that I just went through. And what it is, it's a structured architectural design language for complex systems. It captures that system decomposition, the interactions among the elements of the system, behavioral allocations, and it even captures the mechanism by which you would want to specify the deployment of that system. And it enables all those attributes that we saw previously. And what's really interesting about this, I told you early on that this is a subject that I'm passionate about. What's something I'm passionate about for probably 5 or 6 years now, because it feels like a gap in our industry. How do we break down that wall of confusion? And so we spent years researching this challenge and millions of dollars researching this challenge, and all kinds of experiments and approaches were tried out. This is what our team landed on. And today I'm super excited to announce that You can try it too, because now it is formally published under an MIT open source license on GitHub. There's the links below if you want to go try it out. Right now, everything's set up to operate through command line. I haven't tested in the pure open source environment, the Eclipse plugins that give you immediate feedback of the quality and correctness of your architectural models. But I think it's a really cool thing. And one reason I think it's a cool thing, I never talk about where I work and all that in this forum, but you can see here, this is a Northrop Grumman product. This is the first time that our company has ever published anything developed under IRAD especially of this magnitude of investment as an open source project. And it took me over 14 months to go through the process, deal with the lawyers to get this thing done. And I'm really excited about the opportunity to see what people think about it, to see if they find it valuable or useful. My dream would be, IBM saw something from here, said that's a great idea. Let's incorporate that into a commercial model-based systems engineering tool and help fill some of the gap that our customers experience. On the right of the screen, you can kind of get an idea. This is a simple model that I copied out of the documentation that comes along with this publication. There's actually 2 books that we wrote associated with it that are published in the repos as well. And you can see we capture the inputs and outputs of the elements of the system, those model elements. And then where you see the scenarios, it should look familiar to those who've seen some of the demos we've done in the past. It's the adoption of the behavior-driven development approach, given, when, then constructs, except this gives you a formalized structure that allows you to validate those. So we create verbs, and you'll notice things like the term system track here is actually an element of input. So I have traceability between my interface specification and then the behavioral specification that comes with it. So it gives you an idea of what kind of linkages and traceability you can start to achieve. This is really just scratching the surface of what it does. Another example to look at decomposition. I thought, well, what's going on in the world? The US just launched astronauts to the International Space Station. And I thought, well, that was a really cool thing. So here's an example of what a model for an ISS crew launch system might be. It really starts out that first level of decomp with 2 key parts, a launch pad and a space vehicle. And then you take that down to the next level of decomposition and go, well, it's got a stage 1, a stage 2, and a crew capsule. You would, in our domain, continue naturally decomposing that further and further and further until you get to individual piece parts or capabilities. And I see this top-down decomposition repeated over and over again, system after system that I worked on in the domain. And I think this gives us new ways to think about and construct and build traceability. One other element of traceability I did want to highlight here is the traceability to the requirements. So we can capture metadata with every element or sub-element of the model. And now I have direct traceability from my model to my model-based systems engineering constructs, which I think is hugely valuable. And the reason I think that is because I've seen different programs and different teams use this approach to allow them to do things like automate documentation. Now I've got a configuration managed artifact that gives me all the linkages to all the pieces, and I know how to go pull it together, and I can start to structure and generate all these documents that we spend hundreds and thousands of hours on all the time. Turn that into a work product, turn it into a report that comes out of a pipeline. And it's when you start to see those kind of changes happen, I think it's super exciting because it drives to what we're really trying to get to: affordability, quality, because you can automate quality checks as part of that, and responsiveness. Whenever I see an issue or I need to make a change, I can use the automation to ensure that my systems engineering is complete and of quality, get it into the development context with full traceability, and then drive the delivery of that new functionality out in the system. So I kind of just talked through this, but you know, how does it work? Well, I think it's not competing with model-based systems engineering traditionally. I think it's actually very complementary. But I think it's filling a gap that exists. Having that architectural specification that gives you the linkage between your interface specifications, your behavioral and performance specifications that tend to be captured in your model-based systems engineering environment, tying those down to acceptance specification using some kind of a BDD construct I represent with Cucumber here, and establishing crisp traceability that's rigorously configuration managed and feeds to downstream teams, I think is something that's really important. I've seen teams use this technology in a number of different places where they're making updates and changes to their architectural specification, you know, 10, 20 times a sprint. And you can really see cool interactions and actually see the system evolve rapidly as you go through the cycle using the process, standard processes. So I think that's important to say. It's standard processes that we would use in any other element of system development. What's also important to mention is it's also hard for traditional systems engineers, I'll say, to kind of get their heads around. You almost need someone who's a little bit fearless, who's willing to work in structured text rather than what's often presented in model-based systems engineering, you know, kind of boxes and lines and tables. So getting into that structured text world does have a learning curve and is a bit of a barrier to entry. But when you get a team together who understands the underlying principles and why it's important and how it helps them deliver, I've seen it create some really impressive and valuable outcomes. So that's our whole meetup for today. And that's it for 2020. Frankly, I'm not sad to see 2020 go. I can't tell you how much I look forward to 2021 getting back to some kind of normal. I can't thank you all enough for joining and participating in our meetup today. And I know it's been tough doing this virtually for the last few months, but I do want to say, have a merry and safe Christmas holiday and enjoy your family and some time off. So that's my presentation. We always end with some good references. And thank you all for coming.